In this video, we are going to see about allocation methods. Here there are three types of allocation methods: contiguous allocation, linked allocation, and indexed allocation. So before that, we can see what is allocation. So we have seen paging, where the pages or where the data are stored in the physical memory. And here we can see how the pages are allocated in the physical memory. So that is called allocation method. So there will be some methods for allocating these pages. So that is called a allocation method, and here we are having three methods: contiguous and indexed, and finally we are going to see about the linked allocation. So first we can see about the contiguous allocation. So these algorithm suffers from the problem of external fragmentation. So already we have seen what is external fragmentation, and here while doing this allocation method, contiguous allocation method, we will face this external fragmentation. The thing is, the spaces will be there, the empty spaces will be there, but we cannot allocate the pages in between. So because the pages will be scattered here and the free pages will be scattered here and there. So we cannot allocate that particular pages in these free spaces. So that is called external fragmentation. So we can see how the contiguous allocation works. So see the right side, there is a directory, and we are having three columns. One, it is file, start, and length. File indicates the file name of each pages, and start indicates the starting address, and then length indicates the length of the file. So the first file, it is count, and the starting address is 0 and the length is 2. So it is occupying the first two spaces in the physical memory. And similarly, the second one, tr, starting address, it is 14 and the length is 3, so that it is 14, 15 and 16, and it is occupying these three. So in the way, the content inside the directory will be uh, the pages inside the directory, that is, or the files inside the directory, it is given there, right? So all will be allocated in this way. And what happens is, at last, if you see here, so many empty spaces are there, 2, 3, 4, 5, etc., etc. So if any other pages want to be placed, we cannot place that inside. That is called external fragmentation. And now we can see the second type, that is linked allocation. So linked allocation is all the files will be linked together, and this will be uh, maintained in a table that is called a file allocation table. So see the directory, the file name is Jeep, only one file name is there, but the starting address is 9, ending address it is 25. So it will be starting from the 9. See here, the starting address, it is 9, and here we can find inside the 9 we can find one index number. Okay, so that is it is I think it is 16. So automatically it is pointing to the 16th address, and here, yeah, in that block we are having 1, it is pointing to 1, and inside the 1 it is having 10, so it is coming to 10. In the 10 it is giving 25, and it is coming to 25. So 25 indicates minus, that means up to this, only up to this, no more files or no more indexing is there. So see here in the directory, it is the ending file. Okay, and due to the not it is not the picture is not clear, and so we cannot see the index number clearly. Once again I will say, like, the starting address is 9, so that it is coming to 9. Inside that, the index number, it is not 1, actually it is 16, and now it is coming here in the 16. Here inside that we are having 1, so that it is coming to 1, and in the 1 it is 10, it is not 1, it is 10. So it is coming to the 10. Here it is 25, so it is coming here, it is -1. The meaning is it is completed till this, and it is the end of the directory end file. Okay, and so this is the example file allocation table. So see here, directory name, it is test, and the starting block is given here, and inside the starting block we can find one index number 618, And when you go there and there, we can find one index number 339, and it is the like that it is going here and there. And when you find -1, it indicates that that is the last end of the directory, so it will be completing that. And the last method is indexed allocation. So uh, there is no link there, or there is no contiguous. So instead of that, here we are going for the indexed allocation. So see here the directory. Here we are having one file name, that is Jeep, and index number, it is index blocks, it is given as 19. So it will be considered as the index number. So see the right side block 19, we are having a lot of numbers. All these are the pointers. All these are the pointers where this 19 is pointing to. So 19 is pointing to 9, 16, 1, 10, 25. All these things it is pointing, and -1 indicates nothing is there. So all these files 9, 16, 1, 10 and 25, it is indexed in 19. So in the directory we are not going to give all those numbers. We are giving only the index block. Okay. So in this indexing, we are having multi levels like direct block, indirect block. So instead of having only one indexing, we can also have the next level. Okay, second level indexing, third level indexing, everything we can have here. So first directly the blocks are indexed together, and that we will be calling it as direct block. And the next level it is called indirect block, where this indirect block is further divided into single indirect, double indirect and triple indirect blocks. Okay. And in this topic, we learned about allocation method, how the pages are allocated in the physical memory. And we have seen three different types, how the pages are allocated using these three different types. Okay, thank you.